This problem just requires you to know the properties of waves. So, Alan and Beverly are on opposite sides of a large room. Alan says something to Beverly. Beverly does not hear him. And Alan repeats the message louder. So what they want to know is what is different about the second sound wave compared to the first one? Well, for this you need to know a couple of things. Number one being that the thing that affects the loudness of the sound is going to be the amplitude. So you're going to be looking for the answer choice that is related to amplitude. So the first choice says the second wave travels to Beverly more quickly. That's not true because the speed of sound in any medium is going to be constant. So we know it's not A. The second wave reflects more off the walls of the room. Depending on whether there's constructive or destructive interference, that could make the sound louder or it could make it quieter. The air molecules disturbed by the second wave undergo a greater displacement from their equilibrium positions. Okay, that's a possibility. The air molecules disturbed by the second wave are on average more closely spaced. Even if that was true, ask yourself, how would a person saying something louder cause the air molecules to be more closely spaced? That would require them to actually compress the air molecules. And while there is compression in a sound wave, remember it is a pattern of compressions and then rarefactions. And then compressions and rarefactions. So it's not that everything is compressed together, it's the actual movement of the compressions and rarefactions through the air. The one of these that is going to be the closest to amplitude would be a greater displacement from equilibrium position. And if you'll remember, the definition of amplitude is your displacement from the equilibrium position. So your correct answer is C. So if we take a look at the answer key, we'll see that increasing the volume increases the amplitude, that increases the displacement.